The James Webb Telescope is our eye in the sky, peering deep into space to bring the universe closer to us. The impossible has been solved and science has been broadened in focus. The James Webb Telescope captured a comprehensive image of Proxima b, our closest exoplanet neighbor, during one of its orbits. However, something strange happened. What could it be? And what mysteries did the James Webb Telescope still solve? Stay with us to find out what this trend means and why the world's largest space observatory came as no surprise. The James Webb Space Telescope, JWST, was built with the goal of revolutionizing infrared astronomy. It has surpassed the capabilities of its predecessor, the Hubble Space Telescope, by allowing observation of objects that were previously inaccessible due to age, distance, or obscurity. It includes advanced equipment with high sensitivity and resolution. This revolutionary energy opens up many possibilities for astronomical and cosmic research. Astronomers have discovered 6 giant galaxies since the beginning of the universe, and they have discovered something amazing. These important properties can change our understanding of the nature and evolution of galaxies. The powerful infrared instrument of the James Webb Space Telescope collected the data, and the findings were published in the popular journal Nature. What the Earth looked like 13.5 billion years ago, when it was only 3% of its current age, can be seen through these facts. It is amazing that these hypothetical galaxies, 500 to 700 million years after the Big Bang, have already reached a level of maturity similar to our 13 billion-year-old Milky Way galaxy. The stars of these objects are estimated to have billions of times the mass of our Sun. According to this study, one of the stars in these galaxies could be as much as 100 billion times the mass of the Sun. The mass of the stars in our Milky Way is equal to 60 billion suns, which helps to understand this. As a reminder of how vast and complex the universe is, this discovery challenges our previous assumptions about the nature of galaxies. It also provides a fascinating insight into the early stages of galactic evolution. You will be surprised by what happened after the discovery of the James Webb Telescope, which has great implications for this research. Erica Nelson, one of the authors of the study and an astrophysicist at the University of Colorado Boulder, was surprised by the rapid growth of galaxies and the number of stars like the Milky Way. He said these findings were surprising. He also discovered a planet in the Centaurus B star system that is 11 times larger than Jupiter, the largest planet in the solar system. Because there are 2 stars orbiting the same mass, the Centaurus B star system is known as a young binary system. The distance between our planet and this star system is great, about 3,125 light-years. Centaurus B is one of the largest planets ever discovered. It revolves around 2 stars that are more massive than our Sun and have 6 to 10 tenths the mass of our Sun. The Centauri system is the largest system known to host a planet. Additionally, Centaurus B is known to have the highest temperature among host star systems. The 2 stars Centaurus B, also known as Centaurus A and Centaurus B, are about 15 million years old. On the other hand, our Sun, a G-type main sequence star, is much older, more than 4.5 billion years old. Despite the fact that the Centaurus stars are still young, they have already undergone several stages of stellar evolution that have shaped their properties and influenced their future evolution. Researchers hope to find small, young galaxies early in the universe's evolution. Ellebra, the study's lead researcher and a researcher at Australia's Swinburne University of Technology, called these galaxies monsters that appear to have aged rapidly. Given the unsolved mystery of how quickly these galaxies reach maturity, scientists are curious and eager to learn more about this phenomenon. They also found Proxima Centauri close to the star Centauri B, which is even more exciting. A red dwarf star less than 4 light-years from Earth is Proxima Centauri. It is known for the numerous and powerful flares of radiation it emits. These powerful bursts of stellar energy have a profound effect on the planets orbiting the star. The radiation released from these flares could adversely affect the surface and atmosphere of Proxima Centauri B, potentially destroying the life-supporting atmosphere. The intense radiation from Proxima Centauri's flares could be harmful to life on Earth. On Proxima Centauri B, complex life might have trouble evolving if they were exposed to high radiation levels that made it hard for them to survive and reproduce. Despite these obstacles, scientists and astrobiologists are intrigued and excited by the possibility of a life-sustaining environment on Proxima Centauri b. Using sophisticated computer models similar to those used to study climate change on Earth, researchers have discovered that Proxima Centauri b can maintain vast areas of liquid water on its surface under a variety of conditions. This exciting development significantly boosts the probability that the exoplanet can support a variety of life forms. Scientists still don't know much about the planet next to Proxima Centauri, despite its proximity. The mass of this planet is 1.3 times that of Earth, and it orbits its host star once every 11 days. Because of the lack of information, scientists eager to learn more about this fascinating celestial body face a unique challenge. As a result, we face an important question. Is life possible on Proxima Centauri b? Proxima Centauri b is a planet that orbits far enough to have enough starlight to keep its surface warm enough to keep it above water. It lies in the habitable zone of its parent star. This large area in the habitat indicates that there is water on the surface of the planet because water is essential for life. However, it is interesting to note that the planet Proxima Centauri b is tidally locked due to the strong gravitational pull of the star's close orbit. A tidal lock is similar to the Moon's relationship with Earth, where only one side is visible from our point of view. Tides lock when the planet faces the star on one side and remains dark on the other side. There are two possible configurations for Proxima Centauri b's atmosphere. Early in Earth's history, one of the things that probably happened was that water cooled and released hydrogen into space, leaving only oxygen or carbon dioxide in the atmosphere. If Proxima Centauri be formed from a star or a primordial hydrogen gas, the water flow would be low. For this reason, it is possible that Proxima Centauri be retained its water source throughout its inception. If a planet had an atmosphere, it would contain oxygen and carbon dioxide. When these gases interact with the star's magnetic field, they can create auroras that can be seen from Earth, suggesting that the planet has a magnetic field. There is more. Climate models, such as the general circulation models used to model Earth's climate, have been used to simulate the atmospheric conditions of Proxima Centauri b. These models take into account the tidal lock of the world, the presence of water and carbon dioxide, and more. Guaranteed. The conditions of Proxima Centauri b have many consequences. The planet will be completely or partially covered in ice. A planet as big as an ocean or a small body of water. Vacancies of all types of land are also possible. Some examples point to unusual features such as eyeballs and crab-like areas filled with liquid that look like claws emerging from the equator. In addition, the researchers hypothesize that there is an ocean beneath the surface of the thin, slow-moving ice sheet that varies in thickness over time. Using climate models, scientists were able to examine the conditions on Proxima Centauri b and speculate about the many possibilities for this distant planet. So, could Proxima Centauri b support life? Proxima Centauri b's existence is challenging because of the star's intense UV and X-rays. This planet experiences higher levels of radiation, especially X-rays, than Earth. It has 7 to 16 times the amount of XUV radiation in the world, and may have received much more than in the past. This radiation can be absorbed by the hydrogen and trapped there until it reaches the point where it escapes the planet's gravity and evaporates into the atmosphere. The hydrogen in the outer atmosphere of the planet is heated until it is expelled by the energy of the radiation to split the water into oxygen and hydrogen. As a result of this process, other elements such as nitrogen and oxygen are also lost. Although only nitrogen and carbon dioxide can escape, their concentrations are unlikely to decrease significantly on a planet-like surface.